Hi, my name is Abia Clements, and for this experiment we're going to have an introduction to the periodic table, and then we're going to do an activity using copper pennies that are dated before 1982, which is important, so remember that, and we'll discuss it more later. So now to get started, we're going to head inside and get the introduction to the periodic table. So, as an introduction to chemistry, we're going to go over some facts and give you guys some more information. Chemistry can be found all around us in everything we see, hear, touch, taste, and smell. All of our senses involve chemical reactions in our body and are made up of matter. Chemistry is defined as the study of matter and the changes it encounters. Matter is defined as anything that has mass and occupies space in our surroundings that we can touch. All matter contains many different combinations of over 100 chemical elements. Some of the more basic elements, such as hydrogen, chlorine, and copper, are ones we have all heard of, but many we have not. When elements are combined, they come together to create something new. Understanding this, including the basic properties of matter and how elements change when two are put together to make a compound, gives us a better overall understanding of chemistry in our world. Now, the periodic table of elements, which I will show you in a second, is covered in all of these squares. Now I'm going to show you this one in particular, which is copper, as our example, but every square is very similar to this. So we're going to go over this as an example to represent a lot of the other squares on the table. Now, every square has that small number in the corner, which is called the atomic number. Now it starts at 1, 2, 3, and it goes on and on. Every square has a different unique number that continues. The second thing in this square is the chemical symbol, in this case represented as a Cu for copper, but every element has a different name, and so every element has a unique chemical symbol. Then below that we have the element name, which is copper, but every square will have a unique one. The bottom number is the average atomic mass, which again is unique to every single element on the periodic table. And here we have our periodic table of elements. So I want you to take a look at this picture for a second and just see what you see. So a lot of colors jump out at you right away, first of all, right? But right there in the middle, you can see how I just showed you with the copper, there's a square there for platinum, outlining the 4 different things that we just discussed. Now, if you go across the page from left to right and look at all of the columns, each of those columns is called a group. You can see the numbers written from 1 to 18 across the page. If you go from 1 to 7 down to the bottom of the page, those are called periods, all of the rows. Then if you look at the key of colors there, you can see all the different kinds of elements. They're separated into groups based on their properties. These elements are all carefully placed in this periodic table based on how many valence electrons they have in their outermost shell. You may have heard about this in school, and I'm not going to go too much into it, but every element has a different amount of shells and a different amount of electrons, and so as you go right across the table, that determines how many valence electrons it has, which is the amount of electrons in its outermost shell. In this experiment, we are going to be further exploring copper, which is one of the elements on the periodic table we just discussed. Pennies are copper-plated zinc coins with about 2.5% of copper per coin. It's the copper that gives the reddish color to the penny. In this activity, we're going to be observing what happens to the copper when we expose the penny to common household solutions like vinegar, salt, and water. In all of your kits, you guys will find this pen that should be in a package. If you take it out of the package, you'll find that inside the pen is a periodic table of elements. So as we just discussed, this is what it looks like. When you're taking your pen out and you pull the periodic table out of the pen, just be really careful, because if you pull it out too fast or you let it go in too quickly, it might break. So just be careful of that. Now you can put it towards the side because we don't necessarily need it for this experiment. The materials we will be using in this experiment include vinegar. This is my larger bottle, but you guys have a smaller bottle. Salt. This measuring cup, which we will be using for a 1/4 cup measurements throughout the video. And then we have our 1 teaspoon measuring spoon. Our 3 pennies. Here we have our 3 cups. And then we have our Sharpie here to label these 3 cups. And then we also have tape if you choose to write on the tape to label the cups. However, I'm going to write directly onto the cups, but it's up to you. Our first cup is going to be labeled water because that's the only solution that we'll be putting into this cup. Our second cup is going to be labeled vinegar because vinegar is the solution that we'll be placing in this cup. And our third cup is going to be labeled vinegar and salt because we are going to be placing both vinegar and salt in this cup. Now we're all set with our Sharpie and our tape for the rest of the experiment, so I'm going to lay them off to the side. Now I'm going to measure out a 1/4 cup of water. Now we have our 1/4 cup of water, which we just measured out. So now I'm going to take my water cup and pour the 1/4 cup of water in it. Then I'm going to measure out a 1/4 cup of vinegar. Now I have my 1/4 cup of vinegar that I'm going to put in my vinegar cup. And now for my last cup, I need a 1/4 cup of vinegar and a teaspoon of salt. So I'm going to measure out another 1/4 cup of vinegar for this third cup. Now we're all set with our vinegar for the rest of the experiment, so I'm going to put that off to the side now. And then now I'm going to pour my 1/4 cup of vinegar in my vinegar and salt cup. And now we're all done with this measuring cup. Now I'm going to open up my salt and measure out a teaspoon of salt. Now that we have measured out our 1 teaspoon of salt, we're all set with salt for the rest of the experiment, and I'm moving that off to the side. And now we can pour our teaspoon of salt into our third cup labeled vinegar and salt. Now we're all set with our teaspoon measuring spoon for the rest of the experiment, so I'm going to put it down. Now I'm going to take my 3 pennies and put 1 in each cup. 1, 2, and 3. And then what we're going to do is observe what happens to the penny in each of the different solutions. Now, everyone is going to be given this little booklet that is in your kit. Inside, there are 2 charts. And so for this particular part of the experiment, we're going to use this first chart. Find your pencil or your pen. You can use this pen if you want. And after observing each of the 3 cups, you're going to fill in this chart with what you see. Colors you see, if you see spots, if it's shiny or bright, like what you can see going on in the cup. Anything, any detail matters. So what you're going to need is to find a clock or a timer. As I go to find my timer to continue the next step in this experiment, I want you all to know that ideally, as soon as we dropped the pennies in, we should be starting the timer. Now that I have my timer, on my phone or whatever you've decided to use. I've gone to stopwatch and then I start. Again, ideally you should start it as soon as the pennies go in, but if it starts a little bit after, that's fine, no worries there. So as soon as you drop your pennies in the 3 cups, you want to start your timer and observe what happens. And after 1 minute, you're going to write down in each of your cups what's going on. Cup with water, cup with vinegar, and cup with vinegar and salt. After 1 minute, what you see going on. And then you're going to do the same thing after 5 minutes, after 10 minutes, after 30 minutes, and after 1 hour. Now we're at a minute, so you're going to write down exactly what you see going on. So what do you see going on? In the water cup, in the vinegar cup, and in the vinegar and salt cup. What is happening to those pennies? Now at this point, it's been 1 minute, so you want to write down what you see in each of these 3 squares. Then after 5 minutes, do the same thing, and after 10 minutes, you want to do the same thing. Now I would stand here and watch them for about those 10 minutes, and then you could step away and come back after 30 minutes and write down your thing as long as you're watching your timer, and then after an hour, come back again and write down what you see after that. Now that we're approaching our 5-minute mark, we're going to do the same thing and write down our observations. So once again, here's our water cup, our vinegar only cup, and our vinegar and salt cup. So take a look at what yours looks like. Yours may look a lot like mine. And see what's going on. How do the pennies look different? Now that you've observed your cups, we're going to be recording our next set of observations. Again, I'm not filling in my chart as we go because I want to see what you guys come up with, what you see, because it may be different than what I'm seeing in my experiment. So I'm not filling it out. But at this point, you should have these 3 in the first row and these 3 in the second row squares filled out. At this point, we're approaching our 10-minute mark, so we're going to observe our cups again. Our water, our vinegar, and our vinegar and salt mixtures. And then once again, record what you see in this one, and this one for each of your 3 solutions. So now you should have this whole top part filled in, and you should just have this part blank. So now, as we're ticking back down to 30 minutes, we're filling in these 3 squares. Now that we're almost at 30 minutes, we're going to look at our cups again. Again, water, vinegar, and our vinegar and salt. Anything different about the pennies, what the mixtures look like. And again, now we're filming and filling in these 3 squares. Now, as the timer is approaching the 1 hour mark, we're going to look at our pennies again. And now we're going to fill in the rest of our chart, the 1 hour. So we're going to fill in these last 3 squares. Now this whole chart should be filled. So now what we're going to do is we can stop our timer because we don't need that anymore. And then what we're going to do is we're going to take a spoon, if you have a plastic spoon in your house, or you can even use a metal kitchen spoon from a drawer in your kitchen, and then we're going to use the spoon to take the pennies out. So this is my penny with just the water. So I'm going to dump this one here, and then you want to get a new spoon for your other 2 cups so that you have 3 different spoons and you don't mix up the solutions. Now I have my new spoon for my different solution, and now I'm going to take the penny out of the second cup. Put that here. And now I'm going to take my third spoon and take my penny out of my last solution. So now if you want, you can even label on your paper towel what each one is, so you remember. So that was my first water from my first cup. And now for the second one, I had my vinegar. And then for my third one, I had the vinegar. And salt. So now, because these were pre-1982 pennies, they were really dull looking and old looking, kind of like this one, right? But all 3 of them looked like that. Now take a look at these ones. Totally different, right? So you should have notes in your chart that reflect these colors and differences. And what many of you may have written down is that the water looks to be the same as it was at the beginning, but these other 2 have changed colors. They've gotten brighter and newer looking. Most pennies that have been around for a while have dark spots of a compound called copper oxide. This compound forms when the copper is oxidized by its reaction with the oxygen in the air. So now what we're going to do is on our second data table, we're going to do a very similar thing. So again, like I just said, you went over what your pennies look like, so you want to describe that here and answer these questions. And then we're going to start with this data table. So we resetted our timer and we're going to start again. And then we're going to do the same thing. We're going to observe the pennies now out of the cups and on the paper towel, and after 1 minute, 5 minutes, 10 minutes, 30 minutes, and an hour, we're going to again write down our observations on what they all look like and fill this chart. Now that we're at approaching a minute, we're going to take our pen again, and then we're going to jot down observations after 1 minute in these 3 squares. So as you guys can see, as our timer is going down, we're observing our pennies some more, but I cleaned up the rest of my area. I rinsed out all 3 of my cups, and now they're drying so that we can recycle them after, because they have a triangle, so we can recycle them. So while you're waiting for the time to go down and you're doing your experiment and observations and writing them down, I suggest you clean up your area some. Now as our time is getting towards 5 minutes, we're looking in this row and we're going to jot down observations in these 3 squares. from our water, vinegar, and salt pennies. Now we're filling in these 3 boxes for 10 minutes after we further observed our pennies. Filling in this one now. Okay, now that we're approaching the 30-minute mark, we're going to again make observations of our 3 different pennies and then record them in these 3 squares. So our table is almost filled, and then we have one more section to fill when we get to the hour, and then we're all done. Now we're at our hour mark, so we're going to fill in the last 3 squares of our chart so that it's fully filled now, and then make our last observations. As you can see from both your pennies and mine, the penny that was in the water cup appears to be about the same as it was before, and the vinegar and salt pennies appear to be brighter than they were before. The impact of the water on the penny should have barely affected it. It should be fairly similar to how the penny was when you first dropped it in the cup. However, the vinegar's appearance should be changed by the reaction of the vinegar with the copper to appear brighter now. The combination of vinegar and our table salt helps to dissolve the copper oxide and also forms the blue copper 2 ion, which is soluble in water. This allows the penny to become shiny again. As we conclude this experiment, thank you again for participating in our 2020 Virtual Summer STEM Week, and we hope you enjoy the rest of your week and experiments. Keep learning!